You know what time it is. It is. For the Sunday morning paper. Yes. Yes, indeed. Today, for our enjoyment, we will be doing a short philosophy paper. This shouldn't take too long to get through, which is somewhat purposeful because I have a lot of stuff I need to get done today. However, it is... Oh, man. It is in reference to a subject that I find interesting. Whenever I dabble into philosophy, it often is what I gravitate towards. Yeah, so I have not read this before. So I don't know if it'll be good for stream, but we're going to find out together. That's right. And I'm going to lower this mic volume a little bit. There we go. Okay, now we're not going into the red. Outstanding. Okay. I'm going to actually turn down the Roo. 1 sec. Let's okay. There we go. All right, that's a little better. It's still peaks, but not quite as badly. Okay. So let's see, what else did I want to go? Oh, yes. Of course. So technically, as of last night's stream, we have 25 followers, which means once that filters its way through Twitch's whatever's it takes to do the thing, right? We should be making affiliate here. Now that will end up with a couple of complications. I mean, don't get me wrong, affiliate's a good thing, right? We want that. However, that'll end up with things like ads for people who are not subscribed and things like that. I will figure out the best way to do this so that ads are non-interrupting. Yeah. We might have to have like an ad tag or something that pops up so I know when the ads happen. Oh, I should ask Toast how to do that. Anyway, we'll make sure that the ads are not interrupting anything. Yeah, so theoretically we've hit all of our requirements for affiliate, which is exciting. Like I said, it hasn't come through yet, but we'll find out. We'll find out here soon enough. Sorry. Yes. Let's see. Sorry, just trying to make sure. Really? Why are you seriously popping up? How? What? Gertie. What? But like, actually, hold on. What are we in? We're in 4K. What? Oh, is it the YouTube? Is it the tubes of you? Is that what's causing the problem there? Yeah. Nope. Hold on. Yes, actually. Nope. Ayo, that worked. Okay. Sorry about that. I didn't mean to show that. Yes, sir. Okay. All right. Let's do this them thar thing. Hello, Zephyr, by the way. Yeah, sorry, I was just giving a little time to let people filter in if they wanted to. But I think it's time that we start rocking and a rolling. So let's go ahead and open this one. Hello. If we do make affiliate, don't worry, I will make sure that you do not have ads. I will do that. But anyway, good morning to the day and next my gold. So this is a paper that I randomly searched up and found. So again, I have no idea how good it is, but it seems interesting. It isn't too long. And we'll see how this goes. Thank you. Yes, thank you. All right. So a new problem for ontological emergence. I find ontological emergence to be pretty useful explanatory tool for certain things, but we'll see what he says is the problem by Mr. Daniel Hurd. Okay. We don't need to do the abstract. Let's go here. The reductionist program in scientific methodology has met with considerable success. However, scientists have recently begun to uncover phenomena which are apparently resistant to traditional reductive methods of analysis. Such phenomena have been dubbed emergent. I don't know if that's new, but anyway. All sorts of phenomena have been claimed to be emergent, from recurring patterns in, quote, artificial life, through regular behavior in certain chaotic systems, to the mental state of human beings. These and all other putative emergent phenomena have something in common. They may be described as what I shall call emergent predicates. Oh man, this is going to be linguistically based. I can illustrate what an emergent predicate is by citing a simple experimental setup from elementary science lesson. A flask of oil is heated from below by a Bunsen burner. Hot oil rises to the center of the flask, cools at the surface, and sinks around the edges. This leads to rolling convection currents being set up in the oil. It seems natural to apply the predicate is convection rolling to such a system. What? Rolling convection currents. So the current is convection rolling. Okay. There are two interesting things about the predicate is convection rolling. First, it is predictable only of the system as a whole. It would make no sense to say that an individual lipid molecule in the oil is convection rolling. The notion of the motion of that molecule is compatible with many macro states of the system. If anything is convection rolling, it must be the oil as a whole. Yeah, I mean, convection is a is a statistical process, right? So of course, grammatical. Yeah. I think what he's trying to I understand what he's trying to say with it, right? He's trying to say that um the term convection rolling is nonsensical if you're talking about an individual molecule, right? Which I mean is just the basic concept of emergence. Right, because convection is a statistical effect of a lot of molecules moving around at once with with certain forces being applied to them. Anyway, let's see where he's going with this, because we might loop back and take a second look. The second thing to note about the predicate is convection rolling is that it yields predictions that would be very difficult or impossible to derive from relevant dynamical laws plus boundary conditions. I disagree with you. I disagree with you completely. Suppose I drop a marker of some sort into the oil and I want to predict its motion. It might in principle be possible for me to make this prediction on the basis of complete knowledge of the initial micro state of the system and the dynamical laws governing the evolution. However, the task would be so computationally intensive as to be practically impossible. Yet if I use the information that the system is convection rolling, perhaps a generalization, I have discovered about the behavior of such a system, it will be easy for me to predict the marker will follow a toroidal path. Yeah, but you're confusing processes here, right? You're confusing ontological, what's ontologically understandable and what's epistemically useful. Right? So you say the task would be so computationally intensive as to be practically impossible. Kind of, but kind of not. Right? I could, for example, track. I know what he's trying to say, but so theoretically, I could track molecules. I could track all of them. Eventually, decided difficulty of computation. Yeah, which I mean, so he's not wrong, right? It's so computationally intensive as to be practically impossible is not an incorrect term. However, there are a couple ways to look at it, right? The first is I can talk. What do I mean by computation? So, for example, I can make approximations in my computations and generate something called statistical mechanics, statistical thermal physics, and I can compute how the entire group is moving. And that's based on the individual right, if you go into a statistical mechanics course and you go through it, you'll derive the statistical mechanics from the individual dynamical laws, right? You'll start with the dynamical laws for an individual atom, and then you'll start expanding that into statistical mechanics where you can't compute each individual, right? You have 10 to the 23rd molecules floating around. There's, you can't compute that in a traditional way. But those are all derived. The reason why there's validity to how they're operating is that they are derived from the dynamical laws. In fact, this is really cool. The initial some of the initial statements of of statistical mechanics, as were developed in the late 1800s, were initially off, right? They were wrong. And they found, I forgot who, it might have been Maxwell. Someone found, I forget who it was, found essentially a correction term in the mathematics that made it all work out fine, right? When you put in this correction term, it worked. It turned out, but they didn't know where it was coming from, but they knew that they could apply this correction term. Well, it turned out that when they re-derived statistical mechanics using quantum mechanical approaches that didn't exist in the late 1800s, that exact same correction term actually fell out naturally out of the math and out of the mechanics. So they had, for all intents and purposes, developed a mechanism to take into account the effects of quantum mechanics without knowing quantum mechanics was a thing, which is cool. Anyway, again, I know where he's trying to go with this, but I think he's going at it the wrong way. Here's another way to analyze it, right? Yeah, right. It's really cool. Like, they knew there was something off. They were able to find exactly how much it was off and build a correction factor for it, and then later figured out where that correction factor came from. So it's still based in the dynamical laws. Yes, it's computationally intensive enough to be practically impossible. If you were to try and compute it using a standard methodology, you could, right? There is such thing as an analog computer that uses physical systems as the means of computation. So, for example, for a while before digital computers were effective enough to compute Fourier transforms, Fourier transforms were actually computed by optical computers that would be able to essentially differentiate the light into frequency bands, which is, of course, what the Fourier transform does, right? And so they could do it physically and then get the mathematics from that, because they didn't have the computation to do these advanced Fourier transforms at the time. So you could you could set this up, this oil experiment up, as a computer of sorts to compute the processes that are going on. So from that sense, it is directly computable, but it's not computable as by digital computation. There's quirks within the computation process. There's informational problems, right? That cause issues when you try and define computation, right? Part of the computation is having access to the informational content. Anyway, the point being that there are things that you could talk about. What's his name's demon? Oh geez. Maxwell's demon, right? You can talk about Maxwell's demon that's able to have perfect knowledge of a system and things like that. So if something is in principle computational or accessible to computation or not. Anyway, I guess the point being, there seems to be a disconnect between. Well, let's see what he says, because he makes a differentiation here between ontological and epistemological emergence. So let's see where he goes. So emergent predicates are predictable only of whole systems, and allow predications that would be difficult or impossible to derive from dynamical laws alone. The scientific use of such predicates are broad in building, so a thorough explanation of them is desirable. There are two competing sorts of explanation of emergence in the philosophical literature. They differ with respect to what it is that distinguishes emergent predicates like is convection rolling from non-emergent predicates like is in uniform motion. But uniform and convection both have the same problem, which is that they're statistical. Those are both statistical words, right? Anyway. Ontological emergence says that distinctly emergent predicates can be explained through reference to distinct kinds of emergent properties. Okay. Ontologically emergent properties are supposed to be just as real and more homely physical properties like mass and electric charge. A defense of this view was given by Sullivan and Gover in Search for... 1999. I'll have a comment on this in a second. Epistemological emergence, on the other hand, denies that there's a distinct class of emergent properties. Rather, the distinction between emergent and non-emergent predicates is to be explained through references to facts about our epistemic status. Epistemological emergence has been defended in a variety of flavors. A fairly characteristic one is outlined by Baido in Weak Emergence. Okay, this is the weak, yeah. Variables of dynamical systems theory. All right, offers an account with stress. Okay. Right. So I actually take issue with something. So emergence is commonly talked of in terms of properties, right? And my problem with ontological emergence is that it's not an emergence of properties. It's an emergence of novel substance, which has properties. So, to my mind, the reason why you're going to run into problems with this is that you have your subcomponents here, right? That through some, a structural effect get like here, and then we have one here, and we have one here, right? We end up with this. And now, like, you can imagine this as a protein composed of different molecules, right? And this has different properties than these do, right? Characteristically different properties. But the reason why they have different properties... Oh, shoot. Thank you. Thank you. I appreciate the heads up. Yep, hold on. We'll get there. There we go. Okay. So looking at these, right? So these are your components, right? Say these are the atoms making up your molecule. This is the molecule that results from it. And these have different properties, right? These have different properties than these do, right? So again, you could think of proteins, lipids combining into proteins, that kind of thing. But it's not the properties that are emergent, it's the novel substance that's emergent as a that has a formal cause that isn't applicable to these, right? Because multiple of these come up to make this form that's going to determine the essence and thus the properties of what it is. That form is a combination of these subunits, and these subunits are necessarily different in form, and so they have different essence and different properties than this does, right? So the fact that this has different properties is an accident of it being a different substance than these. So therefore, you're using emergence on the wrong thing, right? If you try and talk about emergent properties, it's not going to make sense. You're going to end up with problems. If you talk about emergent substance having different properties, then that solves the properties problem. So I think Aristotle fixes this. But that is properties are a commonly used. Hold on. Let me make sure this lines up correctly. There we go. Nope, that didn't line up correctly. Go on. Nope, that didn't line up correctly at all. Okay. So what on earth did I just do? That is not what I meant to do. I don't know if I would use quite that exact terminology for it. Hold on. We've got to play this game a little. Sorry. There we go. Kind of, in that you end up with you end up with new forms, right? And those new forms are, create new substance because they become a cause of a new substance. But I don't know if I'd call it creation versus transformation. Right, because I don't think there's anything specifically being transformed with the method that they're talking about with the generation of new properties. Right, they're saying there is something new that, at least the ontological version of this, sorry, so strong emergence theory says there are new emergent properties that are distinct that come into being, but they, I think by not grounding those properties in substance, they run into problems. That I guess is how I would say it. Okay. Right, and so weak emergence says that it's all just epistemological. All right. In this paper, I shall raise a new objection to ontological emergence. Shall begin by reviewing. So what will be interesting is we'll see if does the substance. Does substance solve? That'll be an interesting question to see. Oops, you can't really see it, but all I wrote a note for myself is: does substance solve? Is substance solving this objection that he has? Anyway, I shall begin by reviewing a traditional worry that the position is ontologically extravagant. I shall explain why I think ontological emergence need not be concerned by this charge, and then I shall formulate a new worry which ontological emergentists cannot so readily dismiss. Okay, the old problem. A traditional objection to ontological emergence is that it forces us to reject some deeply held intuitions about how to do metaphysics. Okay. I don't know if that's necessarily a valid grounding for your objection, but anyway, I shall call the conjunction of these views ontological minimalism, or just minimalism. Minimalism includes a number of variations in an alchemist theme. It contains axioms like try to minimize the number of classes of elements in your ontology. Entities should not be multiplied unnecessarily. Wholes are nothing but a sum of their parts. Sometimes, but not always. I know what they're saying, right? They're saying explanatorily, does providing a new substance give you an explanatory new thing, right? So I would argue, and here's where property comes into play, right? When the property of the new substance cannot be, it is not splittable, right? So the property of a heap of whatever, like the mass property is additive, right? So you can think of it like this: additive properties are not emergent in any way, right? That's the whole thing. Additive properties are not emergent. So if the only properties are different are additive properties, then it's not a new substance at all, right? The form isn't doing anything. But when the form is causing something that has distinct properties that aren't splittable, that aren't additive, there's some way novel, then you start having something different that needs to be talked about in terms of a different substance. But anyway, but I understand that worry. This approach to ontology is widely admired. I suspect many philosophers subscribe to this view. The old problem for ontological emergence is that it is incompatible with minimalism. For example, claims whole are nothing but the sum of their parts commits minimalists to believing, at the very least, that the properties of the system are fixed by the properties, including relational properties, of its constituent parts. Yeah, they're running into problems by just relying on property. This position is known as mereological supervenience. The incompatibility arises because whereas the minimalist is committed to mereological supervenience, the ontological emergentist is committed to the failure of mereological supervenience, right? So in other words, not all properties are additive. But we know that to be true. Anyway. In the case, for example, of the alleged emergence of mental states from systems of neuron firings, the ontological emergentist thinks that mental states cannot be explained purely in terms of properties of relations between neurons, and so needs to postulate an ontologically emergent properties to fill the explanatory gap. On this view, the interesting states where emergence is going on are precisely those where mereological supervenience fails. Okay. I don't think there's anything really surprising about what he's saying here. Obviously, he's couching everything in the same property terms that causes him problems in the first place. But anyway, the clash with minimalism has led to many to dismiss ontological emergence as a surfeit of metaphysics. It seems as though on this picture there is no limit to the number of irreducible properties. Such dramatic multiplication of basic properties offends greatly against the maxim of minimalism. Although many philosophers might share this worry, I do not think it is strong enough to deter the ontological emergentist. I would kind of agree with this statement, but however, while I agree with this statement, I think this minimalism piece also has a validity to it. In that you have to be very, very careful. The key word here is unnecessarily. Right? When does this become necessary? I think is ultimately what's coming down to, right? So the emergentist is saying that it is necessary when you end up with these he's saying properties that are not summative properties of its components. And people object to say that, well, no, that's that necessity is incorrect. So I think really it all rests on the description of what, or the determination of what unnecessary is. Yes, like right, if you remember the objection, yeah, these are secondary properties or whatever you want to call them, right? And so you end up with this multiplication of properties or whatever, because you end up with all these new things that happen that are different. I think so. This is still a reaction, oddly enough. This is still a reaction to the old metaphysics, which unnecessarily invented these structures, right? These castles in the clouds, without any grounding in reality, and came up with all of these internally consistent but completely invalid methodologies, right? That in no way helped to describe or understand what was happening in reality. And this is what this is what Kant was talking about, and this is what Descartes was talking about. And this is where the minimalism position, I think, comes from, and it's not wrong. In that, it is really easy to develop an internally consistent philosophical structure that is absolutely divorced from reality. Right? It diverges. You might even start with completely valid suppositions, right? You have an internally consistent system, but at some point, one of the multiple internally consistent options that you have based on those initial terms diverges from reality, right? In other words, it's not deterministic, if you will. So that's, I think, an absolutely valid justification for the minimalism proposition, right? I think that's true. You don't want to do this. You don't want to multiply entities unnecessarily. You want to try and minimize the number of classes of elements in your ontology. Yeah, right. So that's what he's trying to say, right? That there's this you end up with a reductive minimalism versus a more holistic systemic view of things. And again, it all comes down to this, to what necessity is. And so I think if you view it appropriately, if you view emergence appropriately as a substantial constructive process, you don't lose the explanatory power of the reductive aspect. Here's why. So let's say we're gonna go like this, right? We have a couple of different components. Oh, hold on. Let me scroll over and then mess up everything all the views I'm trying to make later. Come on. Yeah. Go further this way. Thank you. Okay. Right. So you have a couple of these different like simple components. And you're going to combine them in various ways, right, to make these different substances. And you can see how this very quickly multiplies into this absolutely shenanigans number of possibilities, right? And so, but this, right, over here might be a different substance to this in that it has a different essence. It has a different formal cause of what it is and what it's doing than this does. It might not, right? Just because you connect these things together does not mean you necessarily get something with a new essence, right? Heaps are still heaps, right? Heaps are not necessarily emergent. Because again, in order to be emergent, it needs to have non-additive properties, non-summative properties to them, right? So the property aspect is still there, still part of it, but you have to ground those properties in the emergent substance. But this part of the cause of this substance is not only the formal cause, right? It's also the material cause of these subcomponents, which are necessary for this, right? Because material cause is the cause in Aristotle is a cause of growth and decay, right? So let's take a modernized version of that. It's not just growth and decay, but rather it's the mechanics, the internal mechanics and processes of it. And that has to do with how these things are interacting with each other. Again, you can think about atoms within molecules or anything like that, right? It's traditionally emergentist. you have to be taking these into account, and you have to be taking the mechanics of how these functionally operate, which is, by the way, completely different from how these can functionally operate, right? So the quantum states of the energy levels of these subcomponents are necessary to describe the material cause of this, right? In the same way that the those same mechanical or quantum mechanical properties of this is going to determine how the form of this happens, right? Because the reason why this molecule has the form that it does is because you end up with these different bonds, right? Oh, that's off screen. You end up with these different bonds, and the bonds can connect in different ways, right? And the angles of these bonds are determined by the energy levels and the states of the subcomponents that are composing it, right? So you can't remove the explanatory pieces of the components from this, but at the same time, the this molecule is going to act in ways that are completely and categorically different from how the atomic components of it act, right? So you have the emergence of a new substance, but part of the explanation of this new substance, the novelty comes from the structure, but there's more. You have to take into account more than just the novelty of it. So you have to include those same things that the reductionist wants to include in it. I'm spamming that off the top of my head, but that is what I would say. Oh, jeez, stop doing that. That is what my gut reaction is to this. Okay. All right. Sure. Okay. Okay. If one has a prior commitment to minimalism, nothing ontological merchants can say will be persuasive. Well, that's way to say you have no actual position. You're just saying nah. To adopt ontological merchantism, minimalists would have to reject deeply seated intuitions about how to do metaphysics. This is all really bad philosophy. Yeah, ontological emergentists are committed in advance to emergent properties, and the failure of mereological supervenience are entitled to be equally unconvinced by the minimalist story. You're not doing philosophy. You're yelling at each other across the table. So that's why that's not a valid worry, he would say. Okay, cool. The new problem, this is what I'm curious about. I shall present a problem which the ontological emergentist cannot evade in this way. I shall argue that commitment to ontological emergentism entails some unpleasant ancillary commitments which throw doubt on the plausibility of the position. To justify this conclusion, I shall present a more technical example of emergence drawn from the recent work on so-called organizational principles. Organizing principles are beginning to appear in work in various scientific fields. They are generalizations which apply to heterogeneous sets of phenomena that seem not to be derived from relevant dynamical laws. I think that's kind of what I was talking about before. But anyway, I shall focus on organizational principle in the field of network topology, although my point is intended to apply on any allegedly emergent property. Okay. Network topology is concerned with the arrangement of nodes in networks. The nodes and the connections between them could represent all sorts of physical phenomena. It has recently been discovered that a particular kind of network topology is ubiquitous amongst natural phenomena. This is the scale-free topology, a network of collaborators on scientific papers of the physical routers on the internet, of certain intracellular chemical reactions, and of hyperlinks on the World Wide Web, all exhibit scale-free network topology. Okay, yep. Sure. of primary interest from the present point of view is that all scale-free networks share common organizing principles. Yes, I mean, you see this. This is one of the really interesting things about some of the mathematical analysis of this stuff is that you can find similar mechanics that operate across very, very different areas of study. One such organizing principle is linear preferential attachment. Preferential attachment means that when a new node joins a network, it is more likely to connect to an existing node which is already well connected than to a poorly connected existing node. The linear part just means that a new mode is twice as likely to connect to an existing mode with 4 connections, say, than with just 2 connections, right? So it's not like an exponential thing, it's just a linear connection. Sure. All scale-free networks exhibit linear preferential attachment. This has several interesting consequences, including clustering, which is characteristic of such networks. There was actually a really interesting video about this done by oh geez, who did that? Oh man, who was it that did that? I can see his face and I can't remember. Hold on, I need to look this up now. Let's see. Network. Organize principle. Man, no. It's one of these kind of general. Oh, excuse me. Sorry, I just want to try and find this. Oof. It was really interesting, and I wanted to give it to you guys. Jeez. What is the name of that stupid channel? Veritasium, there we go. Yes, Veritasium did a really interesting video on yeah, I think it came out of can you really reach anyone in 6 steps? So they were looking at the 6 degrees of freedom thing, which is the idea that you can find an interconnection between yourself and any other person on Earth within 6 steps. But they were talking about it in terms of this network theory and the interconnection with the nodes, and it's the fact that you have preferential attachment means that the nodes aren't just singularly attached to each other, so you end up with these super nodes that will distribute across the system. Anyway, so yes, so the same thing occurs in like human interaction and social systems and things like that. Okay, clustering characteristic. Scale-free networks exhibit clustering. Most nodes are poorly connected, but some nodes' hubs are extremely well connected. This leads to clustering around hubs. Clustering is responsible for remarkable error tolerance of scale-free networks, right? Is also responsible for the high degree of susceptibility to attack on the hubs. Yeah, you see this all the time on cyber systems. There are two interesting things about the predicate exhibits linear preferential attachment. First, it is predictable only of whole networks, not of individual nodes. Just as it makes no sense to say that an individual lipid molecule in a flask of oil is convection rolling, it makes no sense to say an individual node in a network exhibits linear preferential attachment. The attachment profile of an individual node is in isolation is compatible with a large number of topologies of the network as a whole. Secondly, if we know that a network exhibits linear preferential attachment, we can make inferences about how the inferences about that network which without deriving them from relevant dynamical laws. For example, I know that the network of collaborators on scientific papers exhibits linear preferential attachment. I can predict that this network will also exhibit clustering. I can make this prediction without deriving it from laws governing the behavior of individual scientists. So the predicate exhibits linear preferential attachment exhibits both of the hallmarks of emergence discussed earlier. It is preferential only of whole systems and allows predication without derivation from dynamical laws. Okay, so far so good. The ontological emergentist would say that exhibits linear preferential attachment is emergent because it picks out real distinct emergent property. We'll see. This is where the new problem for ontological emergentism arises. I shall show that a commitment to this claim that exhibits linear preferential attachment picks out a real distinct emergent property entails precisely the same claim about a variety of whole non-suitable predicates. Okay. I shall illustrate this problem with another example, this time involving the familiar normal distribution. This probability distribution, often called a Gaussian or bell curve, is ubiquitous in nature. It describes such diverse phenomena as noise voltages in communication circuits or the height of adults of Britons. One can explicate the normal distribution using mathematical theorem called the central limit theorem. The central limit theorem states that the large number of uncorrelated deviations from a mean yield a normal distribution about that mean. I would note that the normal distribution is not the only distribution that you get. Anyway, once again, there are two interesting things. The large number of uncorrelated deviations means that the central limit theorem applies only to systems, not to the individual constituents, and the fact that the central limit theorem yields to a normal distribution whose mathematical characteristics are well known allows us to make predictions about systems from the central limit theorem without having to derive the predictions from relevant dynamical laws. Okay, so in the two respects relevant to emergence, there's a striking fit between exhibits linear preferential attachment and instantiates the central limit theorem. But if that is right, then by parity of reasoning, the ontological emergentist must assert that the central limit theorem, just like linear preferential attachment, picks a real distinct emergent property. And it gets worse than this. The argument generalizes to other statistical predicates, like, is a sample mean? So the ontological emergentist is committed to the reification of wholly unsuitable things like simple means. This will yield to an implausible ontology indeed. However, I promised earlier not to rely on intuition. I shall try to show why such an ontology is problematic, why it fails to avert a new problem for ontological emergentism, why attempts to avert the new problem are likely to fail. Okay. So he's trying to say if it's novel, then any statistical property or any statistical property is not necessarily novel. So you can take things that people don't want to say are emergent, right? You can talk about additive properties and the statistics of additive properties and say, aha, therefore additive properties are emergent when we don't want to talk about it that way. Let's see. I think you have to make a distinction within the statistical systems, though. So, here's my counter to it, right? Statistical properties, maybe, right? It might be a definitional property. I'll say something else, which is that statistical properties are not necessarily novel properties, in that they are statistical properties are properties of any number of things, right? So there's no, I would argue that, yeah, one of them is a description of a large number of things as opposed to a novel property, right? Because what he's trying to say is that if you accept ontological emergentism, then that acceptance entails that any statistical description is ontologically novel, right? That's what he's saying. But I think that falls apart, or that doesn't apply if you use a formal cause connection to it. Okay. So I think formal cause does get us out of this a little bit, right? In that, in order for something to be emergent, substance, the form is important. Statistical properties are formally agnostic, right? I don't care what shape my heap is. I can still talk about my heap in terms of a normal distribution. Emergent properties are formally founded because they are grounded in a right. So in other words, probabilities, which granted only exist in a large number of entities, right? But there's no ordering or formal requirement on them, or on a lot of them. So that would actually be, that's actually a really interesting point, right? Because some probabilistic analyses are formally grounded and some are not. So like the normal distribution is not, right? Your mean is not. Your mean, if you're talking about the mean weight of sand, grains of sand, you don't care how those grains of sand are put together, right? You're just looking at a heap of sand. It doesn't matter. They can be put in any number of different ways, right? But some statistical properties do care about formal connection. So I wonder if we could, that'd be a really interesting analysis to look at some of the statistical properties where form is relevant, or where ordering and things like this are relevant, and to compare the two. I think that would be interesting. Anyway, but yeah, I think that gets you out of it, because you can make a distinction between formally dependent and formally independent substances that have different ontological properties. And if you go to substance instead of property, you don't have to worry when just because a new property crops up doesn't mean a new substance has cropped up, right? The new properties are secondary to the new substance. So you can avoid that problem that gets you there to begin with. That's my argument. Anyway, ontological emergentists stand charged with reifying wholly unsuitable predicates like a simple mean. There are two ways which they might respond to this charge. They might bite the bullet and defend the unfamiliar reification which the account is committed. Alternatively, they might draw a distinction between predicates like exhibits linear preferential attachment, which they think picks out emergent properties, and predicates like is a simple mean, which they think do not. Okay. Biting the bullet is not a good option for ontological emergentists, for they're committed to the failure of mereological supervenience. That is, they think emergent properties cannot be explained purely in terms of the properties of the constituents of an emergent system. So, in the case of the sample mean, this amounts to the claim that sample means cannot be analyzed purely in terms of the properties of the data in the sample. Yet this is clearly false. The sample mean is defined as a mathematical operation on the property of the data the samples, their magnitudes. Yeah, this is a completely different type. Okay. If ontological emergentists cannot bite the bullet, they must try to screen off the cases that cause trouble for the account. One option is to try to discriminate on the grounds of efficacy. For example, it's easy to conceive of linear preferential attachment being causal responsibility for the clustering network, bearing causal responsibility for the clustering network of the collaborators of a scientific paper, is far less easy to think that the central limit theorem bears causal responsibility for the fact that the heights of 95% of adult Britons are within 2 standard deviations of the mean. So the ontological emergentist just says that the analysis is only meant to apply to cases involving efficacy, such as the case of linear preferential attachment. This is not meant to apply to non-causal cases, like that of the central limit theorem or the simple mean. This response, however, begs the question. Opponents of the ontological emergentism will deny that any case of emergence involves high-level efficacy. Any causation, they say, goes at a more fundamental level between the constituents of an emergent system. Ontological emergentists then may not help themselves to a criterion of efficacy with which to rule out the troublesome cases I've raised in this view. Okay, but that's not the only response, right? I gave a substance response, not a causation response. It looks as though ontological emergentists are stuck with commitment to the reification of the simple means and the like. Why might one be unhappy with this? Well, I mean, there's an obvious reason why you'd be unhappy with this, right? That you lose your emergence loses its explanatory capability altogether, right? If everything is emergent, then nothing's emergent, kind of thing, right? It can only be one because one suspects the explanatory work done by emergent properties could be done without the need to postulate them. And in fact, there are a number of philosophical analyses of emergence which show that this can be achieved, doing away with emergent properties altogether. These are the epistemological analyses of emergence I mentioned earlier, right? So that's weak emergence theory. The more successful amongst them give a plausible account of the distinction between emergentist and non-emergentist predicates without postulating a new emergent kind of property. Rather, they rely on facts about epistemic limitations with respect to emergent phenomena. But I don't think that's the only way you have to do it. Right? You don't have to go just to epistemology to do this. The old problem for ontological emergence that it entails an excess of metaphysics is a genuine worry. I would agree. You do have to address that. You absolutely do have to address that. Yet the ontological emergentists can easily avoid this by denying the premise. That is, by disputing the assumption that there are only a few ontological primitives. The new problem for ontological emergence is not so easy to evade. It forces ontological emergentists into a dilemma. Either bite the bullet and screen off troublesome cases, bite the bullet or screen off troublesome cases. Biting the bullet leaves the ontological emergentist committed to an absurd ontology. I would agree with that. Screening off the troublesome cases results in begging the question. Neither position is tenable. We should therefore abandon ontological conception of emergence. Okay. So I don't know about this damn there thought process. Yeah, so what he's saying, right, is if I'm gonna say that, okay, first off, everything is couched in properties. So that's step one, right? So if I say a property is emergent, that means that it's not just an additive of the subcomponents, right? There's something novel, there's something genuinely new about this property that isn't just, you can't just add up all the, right? It's not like mass, right? Mass is additive. So the emergentist wants to say, well, there's something, or there's something new. An ontological emergentist would say there's something ontologically novel happening, and the epistemological emergentist would say that, well, you just can't explain it in those terms, right? So they fall back on the, what's explainable epistemically, right? What he's saying is that if you're going to be an ontological emergentist, you end up with a problem. And that problem is that properties that you don't want to say are emergent properties, for example, the mean of what's the mean of a set of a pile of sand, like the mean size of a grain of sand in a pile of sand, you don't want to say that that's emergent. This kind of, right? But it is at the same time some novel property that's not composed of the individual components. So you're stuck trying to say that something like the average is somehow an emergent property, but you don't want to say that because then any statistical property at all is now an emergent property. You end up multiplying these things ad nauseum, right? And so emergence as a philosophical theory breaks apart because it's no longer explanatory to anything, right? So, well, that's the other option, right? So that's one hand of the dilemma. The other fork of the dilemma is that you can say, okay, we can separate these things off as we can separate these things off as emergent versus non-emergent, right? But let's see. Where'd he go? I don't cannot possible. Okay. Right. So he's saying that you can separate things off, right? But how would you separate them off? You look at causal capability. Womp womp indeed. You're looking at causal responsibility, right? So what he's saying is, okay, well, if you don't want to say something like the average is an emergent property, right? Because you don't have, right, the average number of a grain of sand, the average size of a grain of sand isn't just, doesn't exist if you talk about an individual grain of sand, right? So what you, right, but you can say that, but it doesn't necessarily give you any new capabilities, right? So talking about the mean of something is, you can differentiate that by looking at whether or not this new property can have some new effects, can cause new effects that can't be caused by the individual, right? So that's the way in which you can make that cut. But that ends up with its own problems, right? If you try to use causal responsibility as your means of separating out emergent versus non-emergent properties, because okay, let's see. Far less easy central. Okay, so the ontological emergence just says the analysis, right? Opponents of ontological emergentism will deny that any case of emergence involves high-level efficacy, right? So essentially, the response from the non-emergentists to saying, oh, well, causal efficacy is your split, is that non-emergentists will say, well, no emergent property has causal efficacy because there's no such thing as emergence. So everything falls apart, right? The whole theory of emergence based on causal efficacy falls apart because you can trace the causal efficacy down to the most foundational thing, and so you end up back with what's it called? Minimalism, right? You end up back at minimalism, where the only thing that matters is the most basic foundational thing, and then you can derive everything else from it, right? So this is the dilemma that he's saying ontological emergentists are stuck with. So if you want to say properties, new properties emerge and are new, right, and are novel, you're either stuck saying that all of these different properties emerge, like that you don't want to say emerge, and the whole system becomes weighted down and useless, or you're making a distinction that just eventually, if you push it, falls back into the minimalist view, right? Because none of the emergent properties are causally active. Right. That's what he's saying, right? That's the dilemma that ontological emergentists are stuck with. So you can go back to an epistemological emergentism where you can say, well, we can't effectively calculate it, so we can talk about it in this way as being emergent. I think the problem with his argument, the real problem with his argument is that he's sort of assuming, well, it's twofold, right? The problem with this argument is twofold. One, he is assuming that causation is the only mechanism of determining what's emergent versus non-emergent for a property. And two, by using properties instead of substance, right? Because substance naturally gives you a mechanism of splitting apart what is emergent, what is non-emergent by identifying what the form is that gives you new things, right? The form of a molecule is what gives the novel properties to the molecule that don't exist within the atoms. But right, so that form is absolutely essential to that, right? And that form is independent of the individuals. But it's not, but by identifying it as form, you now have new substance, right? You have an entirely new way of reframing this that avoids this causal problem. Because you're not trying to distinguish things purely in terms of their causal efficacy. You're determining things by novelty of substance, novelty of identity, essentially. So that, I think, is how you avoid this, right? I think you avoid. So to my mind, you avoid this through the substance approach. The problem with this argument, independent of that substance approach, is the assumption that this is the only way to do it. I think that's the problem with his argument. He makes a very, very big assumption that is the only way that you can distinguish emergent from non-emergent properties. Even if you want to go the property route, I think that this argument falls apart there. Yeah. So womp indeed. Yeah. So anyway, that is the paper. It was a nice short paper. Still took us an hour and 15 minutes to go through, but or closer to an hour to go through. But it was a nice short paper, but fun because we can attack it and we can look at things, and these are always fun things to discuss. Anyway, still, from the Pinky Peanut Gallery. Okay, go ahead. What does Pinchas have for us? I'm curious to see from the Peanut Gallery. Metaphysics of Scientific Realism by Brian Ellis. Okay, does that go into some of this? Okay, I'll take a look. I'll take a look. Yeah, I think there are easy ways to avoid this. I still think to me emergence is an important element of reality. And I keep coming back to it. And one of these days when I'm not in the middle of my physics PhD, I'll get back to it. Subsystem function and Einstein's theory of relativity. Oh, that's interesting. Yeah. Yeah. I think you can get back to a neo-Aristotelian approach to this that solves some of these problems. I'm sure it has its own problems I'm not thinking of, right? I'm certainly no genius. But yeah, I think it's at least an interesting way to solve some of these other problems that emergence theory has. So one of these days when I'm not in the middle, like I said, not in the middle of my physics PhD, I'll try and do these things. But anyway, indeterminate amount of physics. Oh, Cassira. Yeah. Okay. I will look those things up. Well, Toasty, I'm about to end. Okay, we can go wait for Toasty to come back. I can wait for you to come back if you want. I can sit in the app for a little bit. Okay. All right. So yeah. That was kind of it. Thank you so much for joining the Sunday morning paper. If you have any additional comments, questions, anything, feel free to reach out to me. If you have an idea for another paper for next week that you would like to see, be it in philosophy, be it in mathematics, be it in science, please let me know. Send it my way. Or also engineering. I also am willing to look at those. Other than that, I will say have a wonderful Sunday. I will not try and find someone to raid today. We'll figure that out later. So have a wonderful Sunday. I wish you the best week next week. I will see you guys again on Tuesday. Thanks, Toasty. Have a good one. Goodbye.